All right, quiet everybody in the set. We are hello. Let me test to make sure the sound. Yep, sound is there. All right. So let me just go to the question 18. In a group of 40 people, whenever I see some information, that's me. You might be different, but I already start putting like n is equal to 40 because it's a group, it's not a population. 35% had never been abroad, never been outside. That's what it said. 35% have never been outside of their country, whatever it is. They've never been outside of country.
They're gonna use this English?
What? We're recording. I don't know if you. Two people are selected at random, so I'm going to select 1 and 2. Two people are surrendered without replacement, no replacement. So right there we have a problem because we cannot use the binomial distribution. So no replacement means you're not going to put back whatever you take. All right. Two people are selected at random without replacement and are asked about their past travel experience. So they're going to ask questions about this. Is this a binomial experiment, yes or no? So the first thing that they ask me right off the bat, is this binomial, yes or no? Binomial distribution, yes or no? What do you think? No. Why do you think that this is not?
Yes.
It is?
Yes.
And you say no?
Yeah, because without replacement.
It says without replacement. So no replacement. So the question is, it's not binomial distribution, because for binomial distribution you need 4 things that you need to have. You have to have 4 things. One of those things you need to have is that you have to have a fixed n, has to be fixed. In this case, you have that condition. So far you have that condition. Number 2, you also need to have 2 answers. You have to have, for example, in this case, the question is, have you been outside or have you never been outside? So you only have 2 answers. In this case, this condition, it's okay. But let's see the last 2 conditions. The other condition that you have to have is that each event is independent. Each event is independent from each other. So let's take a look at this problem. If you have 40 people, right? You have 40 people and you ask someone, have you traveled outside of your country? And then you take that person away and you don't have 40 anymore because you already used 1 person. So the next time you ask, you don't have 40, you only have 39. So you have affected the number of people that you have asked. So they are not independent, because the fact that you use 1 person and you don't have the same amount of person next time, you have affected that. It's like having a box of chocolates. If you take a chocolate, you eat it, the box is incomplete. Next time you go, it's not going to be the same amount. You have 1 less. So you have changed the box because you took 1. The only way that you don't change it is that if you eat 1, but then you buy a replacement and you put it there. In this case, it says no replacement. The fact that it has no replacement, you have a problem with independency, and also you have a problem with number 4. The number 4 condition. So let's see, by working this problem, why number 4 is also a problem. So those 2 conditions, especially number 4, is a very strong reason. Every time you hear no replacement, number 4 is a problem. So you won't have that. Question number B. What is the probability that a random sample of two, no one has been abroad? Yes.
How you know? How do you know we don't have the? How you know number 4?
Because I'm gonna explain to you. That's what I say. If you didn't get it by my explanation, I'm gonna write stuff here that it will make it clear, right? So no one has been abroad. What is the probability that in a random sample of two, at least one has been abroad? Some person has been outside. What is the probability at least one person has been abroad? Now, this question you may think that it said, oh, I could actually use the binomial probability because you use the word at least, and you will be inclined to think of a formula. Remember the formula? This is the formula. If this is our okay, you can use this formula. Px qn minus x. But this formula in this particular case cannot be used because you did not meet all the conditions. This is a nice formula to answer my questions, but cannot be used because of the failure of these two. Everybody okay? All right. Did anyone actually did this question? I'm just curious. Huh? You did it. Okay, I want to hear some, because if you only hear me, then you can be recorded, so that would be great. Say, oh, the students are answering questions. It looks great. So what is the probability? How many? There are two questions there if you see it. What is the probability that in a random sample of two, no one has been abroad? So we need to find that question first, right? B has two parts. So let's answer part B. Let me ask you a question. What is the probability that no one has been abroad? So let me ask you, what is the probability of not being abroad? What is that probability? 0.35, right? It was given to you. This is the 35% have never, I should write here, never been outside, right? Never been outside of country. So 35%. Can we also get, even though they're not asking me, what this would be the probability of being outside? What is the probability of being outside? 0.65, because we know that both of them together have to give you 1, right? Is everybody okay? Now, what is this probability? Well, you can either use it as a decimal or you can use it as a fraction. Fraction would be 35 over 100, right? And this one will be 65 over 100. That's a different way. That's a different way of writing. You don't need to write it. So let's take a look again at the question. What is the probability that a random sample of two, no one has been abroad? So let's take a look at the first. I'm going to pick two people. The first person has never been outside. What is the probability that person has never been outside?
1%, 0.2.
It will be, well, let's use this because it's easier to look at that. It will be 35 over 100 the first time you pick a person. But you need to pick two people because there are two of them. So next time, and this is your answer to your question, next time you go, and you're going to have 34 over 99. Because you already used one person. You had 35 people out of 100, right? 100. Imagine a line out of 100 people, and 35 of them have never traveled outside. You pick one of them, but you don't put it back. You say, can you come with me? And then you go back to that line. How many people do you have in the line? 99. And you don't have 35 people who have never traveled outside because you already took one. And that person makes it 34. So that's why the number 4 condition is not correct, because probability cannot change. If this was true, then you will have 35 over 100, 35 over 100, because you replace, you put back the person. But if you don't put back the person, you're going to have one less, right? All right, so let's multiply that. Do you mind multiplying that number? And see what we have. Maybe I put it over here, because over there.
It's 0.119.
11.9.
11.9.
What is it?
11.9.
11.9? Okay. I hope anyone else try it, or just one person?
Hold up. 0.12. 0.12.
But it says 1 1 what?
0. It's 1 2 0.
Oh, 20. Okay. So 12. I don't know if
0.1202.
0.1202.
1202.
All right, so we're gonna use 12 for simplicity. Is that okay? Now, if you look at the back of the not the back, but the bottom of the exam, the answer is 0.117, which is 0.12, right? So remember, sometimes they use a different approximation with the decimals. But I said, if you approximate to 2 correct decimals, I'm not going to care about the extra decimal there. So the answer is basically the same. All right, so the next question, is there another question?
Yeah. It says no.
What is the probability that a random sample, at least one has been abroad, right? One person has been abroad. So can you try to figure that out? I'll give you 1 minute and at least try it. At least one person. All right, there are many ways to do that problem, so I'm not going to be picky about that. While you are copying, I'm going to keep talking so the person is not going to think that the video doesn't have sound. So. All right, try to figure it out. At least one person.
B was, no one has been abroad, right?
The probability, the last question was, sorry.
One has been abroad.
What is the probability that in a random sample of 2, at least one has been abroad? In other words, one of the 2, right? One of the 2 has been outside. At least one. At least one has been. I'm sorry?
0.22.
No, it's not 0.22. It's a. Can I ask you how you got that? Because it's very interesting. Your number is very interesting. How did you get it?
I took the probability of being outside and not being outside and -1 from. Like, I took 0.34. Like 34 over 100 and 64 over 99.
And 64 over, why 64? Oh.
So we're going to take off 1%.
But at 65, they're never been outside, so you don't have to take
Because it's over 100.
60 is not 65.
65.
You're taking it. Being outside, the person who's been outside. Okay.
64 over 100. No.
It's I tell you, I 1 second, because it's a very interesting way that you looked at the problem, but that's not the right answer. Yeah. Oh, I'm sorry. I thought you had your hands up. All right, so let's think about that for 1 second. What is it? It's anybody, at least one person, right? Try not to do any tricks. Just follow the way that I did it, and then don't try to play a trick there, because it's not going to be good for you. At least one means one person has gone outside, at least. So the other one didn't. Does that make sense to you? So let's see if we can do it just using plain probability. What is the probability that the person has gone? You want a person that went out? Yeah, a person that never went out, right? So what is the probability that a person went out? 65 over 100, right? That's the probability that the person went out. But there's 2 people. The second person has to be someone who never went out, because you only need One, right? The question is, whether at least one has been traveled. So this is the second person, but the person has never gone out. What's the probability that the person has never gone out? 35 over 99. Because you took, imagine 100 people, and out of 100 people, 35 never went out and 65 went out, right? So if the first time you take somebody out, you don't want it to be out, that will be 65 out of 100. But the next group is still 35 because you haven't touched the 35, but you don't have 100, you have 99. So because you already took one from here. This is one person, this is the second person. I don't know if you sure you get it? No, I know you didn't get it. So imagine you have 100 people, and I'm not gonna write 100 little people here, but you're gonna have, so this is 1, 2, 3, 4, 5, until you get to 99, 98, 99, 100 people. So can you picture that completely? Because I didn't do it completely. Out of these people, 65 of them, I'm not gonna write 65 completely that, but 65 of them are never gone out. I'm sorry, they went out. Yes? And also we have 35 people that never left. Oh, sorry. 35 never left. Is that okay? How many people do you have in total? Total, we have 100. Does that make sense to you? Yeah. All right. So I want to take one person out that went out of the country. How many people went out of the country? So I'm going to take from here one person from there because that's what I want. If you take one person from here, let's take that person out. You took out of 65, out of 100, you have 65 choices. That makes sense? Yeah. Okay, but you took one out. So now you come back again, and I said, I want to take another person out, but this time I want to take someone who never went out. How many people you have that never went out? 35 people. You still have the 35 because you didn't take from this group, you took from this group. So 35, you still have your 35, but you don't have 100 because you took that person out. If you took that person out, you only have 99. Does that make sense? Okay. So could you multiply that? Help me, please multiply that. 0.23. 0.23. You are already simplifying the decimal. So you should not simplify the decimal until all the way at the end. Yes? But I'm going to use this for now. At least at this moment, you should be using 4 or 5 decimals.
0.2.
And then you can do that. Now, why do you keep subtracting? Because you saw it in the back, or why do you want to subtract it from 1?
Because I remember doing it at home.
Right, but you need to have a rationale, right? Why is that the case?
Can you go back to the question?
Yes, I can go back to the question. The question is, what is the probability that a random sample of 2, at least 1? What does it mean, at least 1? That's the problem. This is 1, but at least 1 could also mean what? It could be, at least 1 could be 1 or more. So that's a lot because I only did 1, but it says at least 1. So I think it will be too much trouble to keep saying, okay, how about this? How about that? How about that? So you understand? At least 1 could be 1 or more. Well, we have so many of them, and I'm not going to keep doing this over and over and over again for each person. So the problem that he keeps saying is that why don't we take, instead of doing everything, why don't we just take one, which is everybody, and subtract this one?
Yeah.
And what do we have?
0.80.
0.87, right?
Yes.
No.
No.
78, sorry.
77.
What? How much?
77.
0.77?
Yes.
Okay, I think, right,
What's 78?
right.
Yeah,
77.
77. But this will be 0.77, but this is not the answer. I tell you why. I just discovered something.
Use the table.
No. That's not the reason. That's not the reason why this is not the answer. Because this is one person. At least one person. This is one person. So the only way to do this problem is to pick everybody that could have gone. Everybody, the opposite of this. Let me tell you what the opposite of this is, right? So let me take a person that never went out. Never went out. And the other person never went out. Okay? Never went out. If you take those two, what do you have left?
The people that
At least one person that went out. In other words, if you take the only way that this will make sense is if at least one person went out. So that means that one person didn't go. If I said to you, listen, at least one of you will pass the class. At least one of you will pass the class. What does that mean? It means at least one could be 1, 2, 3, 4, 5, 6. In reality, what am I saying? At least one of you. So, what am I taking away?
One person.
So, 1 is okay, 2 is okay, 3 is okay, all the way to how many students I have. What's the only one that is not okay?
0.
0. At least one. If I say at least 2, who is not okay?
1 and
0, 1, and 2. If I say at least 3.
No. At least 2 is okay.
At least 2. Yeah, 2 is okay. So by 0 and 1. So I say at least 3. Who's not okay?
0, 1, 2.
0, 1, and 2. So if I say at least 1, who's not okay?
0.
0. So that's the one that I need to get out. And if I do that one, then I have left everybody else.
But we didn't take it.
No, we didn't, because we did 1. Now let's do the other one where never went out. What is the probability that never went out? How many people I have that never went out? 35 over 100. The second can also not be out. 34 over 99. Please do this multiplication.
0.12.
0.12? Okay, 0.12, sorry. 0.12. And now I'm going to do the minus, because I'm just going to eliminate the 0. What do you have left?
0.88.
0.88.
So this is the correct.
This is the correct answer.
How about the other one? Is not correct.
The other one, no, because here you're eliminating one that went out and one that didn't. You eliminated each one of each. And that's not what the question was. The question is eliminate everybody, because at least one means everybody. Everybody, it's okay, except the 0. That one is not okay. So this probability is not okay. Which one is not okay? 0.12. Everybody else, it's okay. I don't know if you might want to review this and think about this for a second. I don't. If you think about it this way, if I said to you, at least one is going to pass this class, and every teacher should say that. What it's really saying is that everybody has a chance. At least one. That means everybody has a chance. Who's the one who doesn't have a chance?
0.
0 doesn't have a chance. So if these are names of people, 1 is okay, 2 is okay, 3 is okay, 4, 5, 6, 7 is okay. The only name that is not okay is 0. That should be eliminated from that. At least 1. So I eliminated that 0 that you don't want because it's at least 1. So this one is out. And everybody else remains okay. So it makes sense. 88% of the people have a chance. It should be very high, the probability. If I said everybody has a chance, right? Almost teachers always said everybody has a chance to pass, even if it's a lie. But